probability function on omega. Okay. So let's just take some event E, let E be some event in omega. Okay. So let's say this event actually occurred, right? So let's imagine we have a multiple choice problem, right? So there are 4 choices on this multiple choice problem, okay? And so I ask you, you just guess randomly, okay? And I ask you, what's the probability that you get this correct? So there are 4 choices here, right? You're just going to guess randomly. So what's the probability that you guess correctly? What's it going to be? 1/4, right? So let's say I told you that that the answer is not D. Okay. So here the probability is 1/4. So correct. So the probability that you guess correctly would be 1/4. Right. So let's say that I told you that this D. Let's do this. Let's put the D here. So A. What if I told you this was not the correct answer? So now you have this extra information that D is not the correct answer. So now you know for sure you're not going to choose D. Okay. So what's the probability you guess correctly here? Here. So what happened was you had this sample space and you had a probability function on that sample space where you thought the probability of each of these occurring was 1/4. But then all of a sudden you have this new information that this event where the outcome is E, or the outcome is D, this event where the outcome is D, that can't occur at all. Okay? So now you're forced to change your probability function because now, whereas here you originally thought that this had a probability of 1/4, you thought this was possible, now you know that that's not possible, so it would be better to assign a probability function where this has a probability of 0. Okay? So now you just have to take this old probability function and you turn it into a new probability function that reflects the fact that you know this event can occur. So this is what this conditional probability will be. So if you have some probability function P, that would be like this P over here, and then I have some event in this sample space. So here the event would basically be that the event would be the correct answer is not D. Okay? So if you have this, then you can define another probability function. So probability. So probability function. So let's call it P sub E on omega by this. So I have this new probability function called P sub E. And if you want to find, so you take some f in omega, and you want to find the probability given E of f. Okay, so you define this to be, take the probability of the intersection of these two, divided by the probability of the thing you know. Okay. I mean, so this PE, this function PE, so we call this PE. PE, the conditional probability. Function based off of P on omega, given that E has occurred. And then, so I guess, also you might see it like this. So, so you read this. You read this thing as the probability of F given that E has occurred. Okay.
Can it also be P?
Yeah.
Or the E?
So they'll write like this sometimes. So they'll write P, and they'll write F first, and they'll put a line here, and then they'll put an E here. This is what P is. So this thing is the same as this. So I don't like this notation with the bar there, because sometimes I forget which one is the event you're assuming has occurred and which one is the event that so here it's clear that you want to find the probability of F and you're assuming that E has occurred, right? But here, I mean, you might be confused which one is going down here and which one am I assuming has occurred and which one do I want to find the probability of. So wait, what?
If you read it, probability of F given E.
Yeah, so you would do it like that. So I would say, you just read it straight across. So you imagine this is in here. You say, I want to find the probability of F given that E has occurred. Okay. So I'm going to use this though, but I think the book and the homeworks and the exams will probably have this notation. So this just means you find the probability of this thing given that E has occurred. Okay. So let me show you some examples of this. So we do this with units. So let's say you have this. So you have an urn. It has 8 balls. So 5 are red. And 3 are green. And so what you do is you have 1 ball selected. It is replaced by a ball of opposite color. Okay. And then another ball selected. Selected. So we'll let E be the event that the second ball is green. And then I want F to the event that the first ball is red. So I have this experiment where I have 8 balls in this urn. I'm going to choose a ball. I'm going to look at the color, and then what I'll do is I'll throw that ball out, and I'll replace it with another ball that is of different color. So I want to find probability of E, the probability of F, the probability of the intersection, I want to find the probability of F given that E is occurred, and the probability of E given that F is occurred. Let me draw a tree diagram. You'll have you draw the first ball. So if you get a red ball or a green ball, and then you'll do this again. So you get a red ball, a green ball, green. So you need to find all the probabilities for those branches. So when you first choose the ball, so the first choice that you make, what's the probability that you pull out a red ball? 5/8. So there are 8 total balls earned, and 5 of them are red, so this probability is 5/8. What's the probability that you pull out a green ball? 3/8. So if you pull a red ball out of the first time, right, then what's the probability that you pull red the second time? What? So when you pull out, so if you pick a red one, right? So you pick a red one. So if you get red the first time, then you throw the red ball out and you replace it with a green ball, right? So we have 5 red balls, right? If you pick a red, you throw them out, and then there'd be 4 left, right? So this is 4/8. And then what's the other one? 4/8. So if you pick a green ball first, then what's the probability that you get a red ball in the second draw? 6/8. So you have 3 green balls, you pick a green ball. That means you throw out the green balls, so now there are only 2 green balls, and you replace it with a red ball, so there's 6 of these. Do you guys have any questions on how I got the tree diagram? So now I want to find these probabilities. So here the compound probability function won't be the same as the egalitarian probability function. Because if you take this outcome RR, so the probability of getting R the first draw and R the second draw would be 5/8 times 4/8. Okay? And if you look at this outcome GR, the probability would be 3/8 times 6/8. So this would be 18/64, and this would be 20/64. So you have these 2 outcomes, they have different probabilities. So this compound probability function wouldn't be egalitarian. But if you had all of these being the same number, then it wouldn't matter which outcome you pick, because if you multiply this times this, it would be the same as if you did this times this, or this times this, or this times this. Okay? So this one's not egalitarian. So if I want to find the probability of E, so E was the event that the second ball is green, right? So I want the event that the second ball is green. So that's RG and GG. So RG and GG. So you'll find the probability of this one plus the probability of this one. So if you want the probability of RG, then it's 5/8 times 4/8. 5/8.